So this is the first question I have taken. This is a buck converter question. So in question we have to calculate what will be the average output voltage. Okay, V not average. One second, duty I have not given here. Let me check what is the duty. One second. So R is 50, L is 50 micro, and duty will be 0.5. D will be 0.5. So in this case, we have to calculate what will be the average output voltage. So how we can proceed? Can anyone tell?
50.
No, that is incorrect. See, if fill in the blanks question will come like this, 2 marks question. First, what we will do? We will check whether this converter is working in continuous or discontinuous conduction mode. Okay. So directly we cannot apply like 30 into 0.5, it will be 50. 15 also will be given in the option. If option will be given, 15 will be there. Okay, so first what we should do, see if 1 marks question will be there, then we can directly tick. But 2 marks question, we should first check either it is a continuous or discontinuous conduction. So how we can check? The
So
main
first
thumb,
find critical resistance.
yes. So IL average should be greater than delta IL by 2. So this is the rule for the continuous conduction. Okay, if IL average less than delta IL by 2, then we can say that the converter is working in the discontinuous conduction. Okay, so I'm going to draw the waveform. Oh, if it will be like this, then it will be just at a boundary of continuous and discontinuous conduction. So what will be the this value delta IL by 2? So when this switch is on, this is plus, this is minus VL. So delta IL will be delta IL divided by T on. It should be Vs minus V naught by L during turn on. Is it clear to all? This one delta IL. So this will be delta IL, and this will be from here to here on period. It will be T on. T on we can write as duty into total time period. Okay. So from here we can see that delta IL will be what is value we can write VO is equal to dVs. So D into to 1 minus D Vs divided by L into F. Is this equation is clear to all? Is it clear or I should explain again? Can anyone reply? It's delta L equation. Okay. So clear? Okay. Okay. So what will be the IL average? IL average will be same as I naught average. IL average will be I naught average. So same equation I can write here. So IL average less than delta IL by 2. So IL average is equal to, we can write I naught average will less than delta IL by 2, and this will be V naught by R should be less than delta IL by 2. And delta IL already I written D into 1 minus D Vs divided by LF. So it will be less than D into 1 minus D Vs divided by 2LF. And further we can add VO is equal to dVs. So dVs divided by R should be less than D into 1 minus D Vs by 2LF. So dd will be cancelled. So this equation we can write as 2L divided by RT. It should be less than 1 minus D. So already this equation I have written previous class for boost converter. Okay, buck boost converter and boost converter. So this will be value of K, and this will be the value of K critical. So if K less than K critical, our converter will work in the discontinuous conduction mode. Okay, is it clear, this derivation? Is it clear to all? So I'm going to write the K critical for all three converters. So K critical for buck will be, it will be 1 minus D. For boost, what it will be? It will be D into 1 minus D whole square. And buck boost, it will be 1 minus D square. So this is the critical value. K value will be 2L by RT. It will be same for all converter, 2L by RT. So this you have to memorize. Okay. If K value, first we will calculate this K value. If K will be less than K critical, then we can say that the converter is working in the discontinuous conduction mode. Is it clear to all? Can anyone reply?
Yes, sir.
Okay. So first we will check this. Okay. So coming to the question, this is the question. 1 second. So 1 second. One second. Okay. So up to here we have explained. So first we will calculate K critical. What will be the K critical for buck? It will be 1 minus D. So it will be 0.5. Okay. And K value is K is equal to 12 by RT. So can anyone calculate this value? Like 12 by RT. So K will be
40 to 10 power minus 3.
how much this value? 2L by RT. So we can write that 2L
F.
F by R. So L how much?
40 into 10 power minus 3.
1 second. See, L F in kilohertz. Frequency is kilohertz.
0.04, sir. 0.04.
We are getting 0.04. Okay. So what we can see here
Less
that
than 0.5.
so
0.
0.04 less than 0.5. So it will be discontinuous. Okay. So this direct formula will not work here. What is the direct formula? VO is equal to dVs. That is for continuous one. So first we have checked this. This is discontinuous. Now how we can proceed? Let's see. So here we can see that at load side, this inductor current and this capacitor current and this is the load current. So here what we can say that, see, here source current we can calculate from this one by applying VO IO is equal to VS IS. This power balance we can apply since we are assuming is at a ideal, like all diode and switches have zero internal resistance and device drop. So this formula we can apply. First I'm going to apply the volt second balance across the inductor. Okay. So inductor current will be like this. It will go and it will be 0. So this will be D1 and this will be D2 and this will be total time. Okay, D2T, D1T and this is total time. So this is D3. Okay, so same inductor voltage we can write. During D1, what will be the inductor voltage? D1 means switch is on. So this will be Vs minus V0. During D2, what will be the inductor voltage? So D2, this diode will conduct. So we can say that this will be minus of output voltage. Okay. And D3, all current will, inductor current will be 0. So in that case, output voltage will be 0. Is it clear? Okay. So here we can apply the volt second balance. So d1 into Vs minus V0 plus d2 into minus V0 should be equal to 0. So V0 common will be d1 plus d2 is equal to d1 Vs. This will be V0. So V0 will be d1 divided by d1 plus d2 into Vs. This will be the equation for the discontinuous conduction. So this will be the charging time d1 Ts and discharging d2 Ts, and for d3 it will be 0. Is it clear up to now? Can anyone reply? Otherwise I will explain
Clear.
again. Clear? Okay.
Clear.
Okay. So this is the equation of the voltage. So how we can derive the current equation? Just we can apply this. Okay. So what will be the source current? So Vs Is we can write as V0 I0. Okay. So V0 I0 will be here. So V0 will be D1 divided by D1 plus D2 into Vs into I0. So Vs will cancel. Is will be d1 divided by d1 plus d2 into I0. Is it clear? This equation, source current equation, clear to all? Can anyone reply? Is this average current equation is clear to all? Source current. Okay. So same equation we can derive from this waveform also. This is the waveform d1 and d2. See, d1, this is d2. So this is total inductor current. What will be the source current? Source current will be the first half part. So it will be the first half part d1. d1 Ts. Up to here it will do, here it will be Ts. So this height it will be, we can write as V0 into d2 by L. This is the source current. And here what we have calculated, source current should be equal to d1 by d1 plus d2 into I0. So Is is d1 divided by d1 plus d2 into I0. This will be the source current. Further, we can write this as d1 divided by d1 plus d2 into I0 is equal to V0 by R. We can write. Is it clear? This waveform is clear to all. This one and this peak value how I have calculated. Peak of this waveform will be, source waveform will be V0 into d2 by L and d2 Ts, d2 Ts by L, and this will be d1 Ts. This is d2 Ts, d1 Ts, and this is delta IL we can say. So from this graph we can see that I2 minus I1. So this delta IL from this graph will be V0 into D2 Ts divided by L. Is it clear to all? Or I will explain with respect to the circuit, this value, how we are getting delta IL. Is it clear? Can anyone reply?
Clear, sir. Clear.
Okay. So see, here we can equate these two equations. Okay. So what will be the average from this Is average? It will be 1 by Ts into area. So area will be 1 by 2 into d1 Ts into V0 into d2 Ts divided by L. This should be equal to d1 divided by d1 plus d2 into V0 by R. So from here we can see that this V0 will cancel. Okay. D1 also will cancel, and this Ts and this Ts will cancel. So we can write here as d1 plus d2 into d2. So it will be equal to 2L by R Ts. Is it clear to all? This one? This equation is clear up to now? So from this quadratic equation, we can derive the value of d2. Okay. From this quadratic equation, we can find the value of the d2. What was the value of k? 12 by RTS. Can anyone tell? So it will be d2 square plus d2 into d1 minus k. This should be equal to 0. So d2 will be minus d1 plus minus d1 square plus 4k by 2. Is it clear to all? The value of d2. Can anyone reply? Is it clear?
Yes, sir.
Okay, okay. So here we can write this equation d2 square plus this d1 is how much? 0.5. Already given this d1 is 0.5. So 0.5 d1 minus k, how much we have calculated? Hello?
0.04, sir. That one. K.
0.04. It should be equal to 0. So see here it will be d2, 0.5 d2. So what will be the value of d2 from this equation? I am also calculating. So
So 0.07, sir.
d2 will be 0.07.
Yes, sir.
Okay, wait. Once we will calculate the k value again. K is equal to 2L by RT. Okay. So 2 into L into F by R. L how much? 50 micro. 50 micro or 50 milli. Can we, if we will put milli here, what will be the answer? Can you check? 50 micro in place of 50 micro. 1 second, milli. I have done. If we are putting milli there, what will be the answer? K value. K I am getting a 0.4. Are a few. Okay. Let's say, no, here I have done mistake. This will be 500 micro. Okay.
Milli means you are getting 40, sir.
Okay, okay.
Whose number?
If we'll if we'll put 500 micro, this here one zero I have not kept. So 500 micro, what will be the value? 2 into 500 into 10 to the power minus 6 into 20k.
Sir, 0.4, sir.
Okay, so this 0.4. Okay, 0.4 and how much 1 minus d? 1 minus d was
0.6.
0.5. It was there previously. See, previously this d is 0.5. K critical was
Sir.
0.5. So 0.4 less than 0.5. Okay, this discontinuous conduction is satisfying. So k value is 0.4. K is equal to 0.4. Okay, so this value we will put here minus 0.4 should be equal to 0. So what will the d2? So 3, 1, 0.5 minus 0.4.
0.43, sir.
0.43. So d2 will be 0.43. Okay.
0.430.
Oh, 0.430. So we can calculate. So what will be VO? VO is equal to D1 divided by D1 plus D2 into VS. D1 how much? 0.5. So 0.5 divided by 0.5 plus 0.430 into VS how much? 30. So this will be the final answer.
Yeah,
0.
16.1.
16.129.
So V naught will be 16.129. This will be the final answer. Okay. So what I will suggest you, if 2 marks question, fill in the blanks type question or like this type of question will be there. So if you will do practice, this much time it will not take. Okay, just directly we can memorize this equation also. D2 square plus D1 D2 minus K is equal to 0. This will be the equation for the buck converter. So this directly you can memorize. From here you can derive the duty ratio D2 and then you can derive the output voltage. Is it clear? Should I move to the next question? Or anyone have doubt, they can ask. Again, I will explain. So here, one question also we can do. What will be the average switch current or those things? Directly we can relate. Okay, how we can anything we can calculate. Like output voltage we know, output current we know. We can calculate the source current. Then inductor current also waveform we can draw, and we can calculate the average value of the inductor current. So you can you can do different kind of question, like you can select any question. Okay, you try to if in gate question, if they are asking something, one parameter they are asking, you can try to calculate other parameters also in the same question. Okay, so next question I have taken from gate previous year only. That first they have given continuous conduction. So first we will solve in the continuous conduction mode only. Later I have changed some data. So after that we will see how it will work in the discontinuous conduction mode. So should I move to the next question, or if anyone have doubt? This is the next question. Anyone have doubt in previous question, or I can start with this one?
Yes, sir. In previous question, how to calculate K, sir? K value 0.4.
Okay, see K already equation I have given here. See how what is the K? K means this for continuous conduction mode, we can discontinuous and continuous. So IL average, if it will be less than delta IL by 2, then we can comment that the converter is working in the discontinuous conduction mode. Okay. So what is the delta IL equation? Delta IL is D into 1 minus D Vs by 2LF. This is for buck converter. Okay. And IL average is I naught average for buck converter. So this will be V naught by R. So from here I have derived this equation. When this value will be less than 1 minus D, we can say that the converter is working in the discontinuous conduction mode. So what is 1 minus D? 1 minus D is K critical for buck converter. Okay. So here I have summarized the K critical value for all different converters. For buck converter it will be 1 minus D. Boost converter it will be D into 1 minus D square, and buck boost it will be 1 minus D square. And K value will be same for all. You can derive by applying this equation. So you will get this kind of relation. Okay. So K is equal to 2L by RT. This will be same for all three type of converter. So this you have to memorize and this you have to memorize. Then you can see this relation K less than K critical. If this condition is satisfying, then you can comment that the converter is working in the discontinuous conduction mode. Is it clear? Just you have to
Answer K equal to 0.04, sir.
No. Mistake I have done in previous data. So data is here 500 microhenry. Okay. So after that we have calculated, then we found that it is 0.4. K will be 0.4. So 0.4 is less than 0.5. It will be still in discontinuous conduction mode.
Now understood, sir. Understood, sir.
Okay.
Thank you, sir.
Okay. So coming to the next question, can anyone tell this will be working in continuous or discontinuous? This is a buck boost converter. So for buck boost, what is the K critical? It will be 1 minus D square. Already I have written here. Or buck boost it will be 1 minus D square. For boost it will be D into 1 minus D square. So here K critical is 1 minus D square. Can anyone tell whether it will be a continuous or discontinuous conduction mode? Just you can calculate K. K value will be 2L by RT. How much? 2 into L, 1 milli into frequency, how much? 25K. 25 divided by R, 10. So
5, sir.
K value is 5. What is K critical? 1 minus 0.75 square. So we directly it is less than 1, so it will be less than 1 only. So K less than K critical. No. K greater than K critical. K is 5.
Greater than, sir.
So
Continuous.
it will be a continuous conduction. So continuous means normal formula we can apply. What will be the output current here?
D by 1 plus D 1 minus D whole square into V naught Vs.
Okay, so first we'll calculate average voltage. So 20 into 1 by 1 minus 0.75 output voltage. How much it will be? Can anyone calculate? 20 by 0.25.
80 volts.
So 80 volt. Output current, how much it will be? 8 ampere.
8 amps.
Okay. So average current flowing through the inductor. So if you apply ampere second balance in this kind of circuit, we'll find that IL average is equal to I naught average divided by 1 minus D. This equation already you
32
know.
amps. 32
So
amps.
so IL will be how much? 32. Correct only.
Sir, for buck boost D by 1 minus D, no, sir.
Okay. We have done mistake. Correct. This is for boost. We can calculate again. This is mistake. Can anyone tell? No. Correct. Like this, you can comment if you are. Sometime in exam also this will happen. We are seeing some other converter and we will apply some other formula. So we should be careful.
3 volts, sir.
How much?
Speed.
60.
60. 60.
This is 60. So it will be 6 ampere. And IL average will be 6 divided by 1 minus 0.75. How much it will be?
24 amps. 24 amps.
24 amps is correct answer. So this is previous year only. I think GATE 2021 question. 2021 2 marks. So same question I have done some changes. Is it clear? I think up to now it is clear to all. This solution 24 ampere. So if it will be a discontinuous conduction, then how we can analyze? Okay. So here I have done some changes. Like switching frequency I have changed to 1 kilohertz. Duty ratio is 0.5. R is 100. So can anyone tell whether it will be a continuous or discontinuous? What will be the value? What will be the K value? 2LF by R. So it will be 2 into L how much? 1 milli into 25. No, here it will be 1.
0.01, sir. That one.
100. So it will be 0.02. No? 0.02.
1, sir. 0.01.
0.02, sir.
This is 100. No? R is 100.
0.02.
Frequency 1 kilohertz. L 1 millihenry. So it
There
will
200, sir. That one. R.
R 100.
Okay, sir.
So
0.02, sir.
it will be 0.02. So what will be the K critical? It will be, or buck boost what it will be? 1 minus D square. So 1 minus 0.5 square. It will be
0.02. 0.25.
0.25. Okay. So K less than K.
Discontinuous.
So discontinuous. So now how we can proceed? Okay. So 1 second. So I'm going to write the first equation for this inductor voltage. So D1, D2. So during on time, what will be the inductor voltage? It will be Vs. And off time, what will be the inductor voltage? It will be, here this is plus, this is minus, it will be minus Vu. And D3, it will be 0. Okay. So D1 into Vs minus D2 into V0 should be equal to 0. And we can write V0 is equal to D1 by D2 into Vs. Is it clear? This will be the final equation for discontinuous conduction mode buck boost converter. D1 by D2 into Vs. So if we will calculate D2, then we can calculate the average output voltage. Is it clear to all? This is inductor voltage VL. Inductor current will be like this. For D1 it will be charging, D2 it will be discharging, and this will be total time period, and here it will be D. Is it clear?
Sir, one second, that D1, D2, please explain, sir.
Okay, see, D1 means switch is on. This is the D1. When switch is on, so it is charging. Okay, switch is off. Okay, so it will discharge in this way. Okay, it will discharge in this way. After this time, this inductor current will be zero, open circuit. Okay, it will discharge by here. So D2 time it is taking to discharging, but it is discharging before the full time period. So this is D1T, this is D2T. This is on time, this is charging time, this is discharging time. But this is, if this will discharge up to here, up to full time, then we can say that boundary of continuous and discontinuous. But it is discharging before that. So this time period for which the inductor current is zero, this is I'm calling as D3. Is it clear?
Yes, sir.
So for this, when this will be on, VL will be VS. When this will follow this path, in that case VL will be minus of V naught. And for current will be zero, this inductor voltage will be zero. This will be open circuit. Okay. So in that case, in this current will be zero, inductor voltage will be zero. So if you will apply the volt second balance, this will be D1 into Vs minus D2 into V naught is equal to zero, and V naught will be D1 by D2 into Vs. So D1 already we know, this is the D1. So we have to calculate the D2 value. What will be the D2? Is it clear now? Is it clear?
Yes, sir. Yes, sir. Clear,
Okay.
sir.
So from this circuit, if we'll see, this is the diode current, this is the capacitor current, and this is the load current. Okay. So directly from here, we can say that the average ID average will be equal to I naught average. Since capacitor average current is zero, average current through capacitor is zero. So the average of this diode current will be equal to the average of the output current. Is it clear? So what will be the average of the diode current? This part, second part. Second part will be the average of the diode current. Is it clear?
Yes, sir. That negative, sir. Second, D2 in D2 period.
I'm going to draw the diode current waveform. Okay. So diode current waveform will be somewhat like this. Charging and discharging. It will be this D2 TS, and this will be TS. This will be ID. So what am I saying? I naught average will be equal to ID average. Why? Because capacitor average current will be zero. So this average current will be, so what we can say that this load average current will be equal to the diode average current. Okay. And diode is second part. First part is the switch from here to here, and second part is the diode. And third part will no diode or a switch, none of them will be conducting. So this is the third part. Is this waveform is clear to all? Diode current?
Yes, sir. Clear, sir. Now.
Okay. So this equation we can apply here. I naught average is equal to ID average. Okay. So I naught average, what we can write? It will be V naught by R. Here we can write, and this will be the ID average. So how we can calculate the ID average? What will be this length? Can anyone tell? See, coming to this circuit. So first part, what will be the VL in first part? VL is equal to VS. When switch is on, VL is equal to VS. So we can write this as D1 VS by L TS. Is it clear? D1 TS into VS by L. When switch is on, VL is equal to VS. LDI by dt equal to VS. And DI by dt will be VS by L. So for first case, what is DI and DT? DT will be D1 TS. Okay. From first part. So delta IL divided by D1 TS equal to VS by L. So this peak we can write as D1 VS into TS by L. Is it clear? Peak of this waveform is clear to all. Otherwise you can ask, I will explain again. Can anyone reply? Already we have
Sir,
calculated this thing earlier.
like this we can't write, sir. Half D2
See,
T2.
D2 also we can do, but I am considering here DS, D1. Why D1? See, that was buck boost, buck converter. So buck converter output side only V0 I was getting. Okay, here I need VS. According to the need, we can do that. Okay, so from this side also we can calculate the peak, but I am calculating with respect to the first this waveform. Okay, so first is the D1, D1 TS. First one was the D1TA. So with respect to this also we can calculate. With respect to this also we can calculate. Is it clear? I'm taking with
Yes,
respect
sir.
to first one. So if you will calculate with respect to this, it will be in terms of D2. I'm calculating with respect to this first one. So it is in terms of D1. Okay, so we can calculate the area under the curve. So 1 by 2, 1 by TS into area. So 1 by TS into 1 by 2 into D2 TS into D1 VS TS by L. This will be the average value of this current. It should be equal to V naught by R. So V naught by R we can write as already equation we have wrote here. So D1 by D2 into Vs by R we can write directly. So V naught by R equal to D1 by D2 into Vs by R. Is it clear? This I naught average is should be equal to ID average. So here it will be cancelled. Some Vs will be cancelled. Vs will be cancelled. Okay,
D1 also, sir.
D1 also will be cancelled. So here TS also cancel. Okay, so D2 square, D2 will come here. D2 square we can write as 2L divided by RT. Is it clear? D2 square
Sir,
should be
again that one critical K value, sir. This one.
same as K. It is coming same as K. So from this equation we can derive the value of D2. What will be the D2? This D2 we will put in this equation, whatever we have derived here. So D2 we have calculated. Can anyone tell what will the value, K value for this one? K value how much we have calculated? 0.02. Okay. So it will be the D2 will be under root 0.02. How much?
0.141.
Okay. So D2 will be 0.141. Now we can apply this formula to calculate the average output voltage. Under root 0.02. So what will be the average output voltage? This question. V naught will be equal to D1 by D2 into Vs. D1 how much? 0.5. 0.5 divided by 0.141 into Vs much? Vs is 20 to 20. So this will be the final value. How much?
70.92.
17.921.
921.
Okay. This will be the final answer. 0.5 divided by 0.141 into 20.
0, sir. 70, not
Sir, that
1.
one
Okay.
boost converter means voltage will increase now, sir.
70, getting 70.
70.921.
70.921. Is it clear? So see,
Yes,
like in GATE till now they have not asked this kind of question. Okay, but in coming years they can ask because level of question are increasing day by day. Okay, so these are the part they have not like they have skipped till now. This kind of question they have not asked. But if you are ready with this kind of thing, then you can achieve like more marks in GATE. Okay, we
sir.
should
So we are memorizing this formula is enough, sir. D2 square equal to
see
2L capital.
directly one formula we can memorize here. So V naught is equal to we can write D1 by under root K for this converter only. Here see, this is D1 by D2 into Vs. So for this one we can write V naught is by Vs is equal to D1 by under root K. Okay, you can memorize this formula also. So K we can calculate. If it will be discontinuous conduction, D1 will be given. Okay, K value we can calculate, and what will be V naught by Vs? It will be D1 by under root K. Direct you can memorize this one. Okay, is it clear?
Good shortcuts.
Directly first you check whether it is a continuous or discontinuous, then calculate the K value, and D1 by K directly we can get the output voltage. Is it clear? For buck converter also we can do same kind of thing. So here like this one, na? This also you can memorize like in terms of K. Okay, D2 we are getting this, na? So this negative part will not be there. So we can write minus D1 plus D1 square plus 4K by 2. Okay, this we can memorize. That will be the value of D2. If you will put in D2, that then it will come in some standard form that you can derive also. Like I'll next class I will write all those standard formula. Okay, all three buck boost and buck boost. In I will do the revision. So for all those three type of converter, this kind of short formula I will write. Like this kind of formula is there. This one is for buck boost. So same kind of formula I will write for all buck and boost. That you can memorize, but sometime plus minus mistake will happen. Okay, sometime plus minus mistake will happen. Then if you are knowing the basic, then also it will be good only. Is it clear to all? Anyone have doubt in this question or explanation?
No, sir. No, sir.
Okay.
Understood, sir.
Clear, sir.
Okay. So now I have taken some easy question only, some easy, like not like this one. So one by one, it will be a kind of revision. Okay. So just get previous year question, we'll solve one by one. So this is previous year gate only. Okay. So switch AC is operating at 100 kilohertz, duty ratio is 0.5, and delta IC is given at 1.6, and I naught is given as 5 ampere. So peak value of current through this switch we have to calculate. Okay. So first we can check whether it is a continuous or discontinuous. R value is given, not given. See, so if we'll write this one, so let's say this is delta IL. Okay, IL curve. This is IL average, and IC how it will be? IC will be IL minus I naught. IL minus I naught. So IC curve will be like this. Okay. So from here, what we can conclude? This delta IC will be same as delta IL. Is clear? So ripple in capacitor current will be same as ripple in the inductor current. Is it clear to all?
Sir,
Anyone?
clear, sir.
Okay. So see here delta IC is given, means we can get that the delta IL is given, and delta IL current is flowing through this switch one in first condition. So this is the switch current first half. First half is the switched current. Okay. So just if average is known, we can add delta IL by 2. That will be the peak value. Okay. And I naught is known, so I naught average is known. What will be the IL average? IL average will be the I naught average. So this value is 5. Okay. So what we can say, 5 plus 1.6 by 2. This will be the switch peak current.
8 amps, sir.
It will be 5.8 ampere. Is it clear? So just we have to see this waveform. This capacitor current and inductor current. So what is the ripple in the capacitor current? Same will be in the inductor current. So just we will average value known. Just at delta IL by 2. So 5 plus 1.6 by 2, it will be 5.8. I think it is also 2 marks question, maybe. But here they have not told like whether it is a like, see, so continuous or discontinuous we can say from here. IL average greater than delta IL by 2. So IL average and I naught average same. Okay. So 5 greater than 1.6 by 2. It means we can conclude that the converter is working in the continuous conduction mode. Is it clear? Clear to all?
Clear, sir. Clear.
Okay.
Sir,
Okay.
how that inductor current and capacitor ripple equal, sir?
See. So continuous conduction, I'm going to draw the waveform again. Continuous conduction, what will be the inductor current? It will be some maximum and minimum. Okay, they say this is maximum line, this is minimum line. I'm telling with respect to some data. Let's say this is uh, 4 and this is 6. Okay, and this midpoint is 5. This average value is 5. So it will be a charging like this one and discharging like this one. This midpoint value how much? This is 5. So IC is what? IC is equal to IL minus I naught. This is I naught and this triangular wave is IL. Okay. So we can subtract the points. So here what will be the value of the IC? Since waveforms are same, so IC will cross the zero axis here. Here also both waveforms are same, so IL minus I naught will be 0 here. Okay. Initial point, what will be the IL minus I naught here? IL is 4 and I naught is 5. So 4 minus 5, it will be minus 1. So it will start
Yes,
from
sir.
minus 1. Okay. Here it will be 0.
Mhm.
Okay. At peak value it's 6 and 6 minus 5 it will be 1. Okay, so here it will be 1. Okay. Again it will go to the minus 1. So here it is minus 1. Here it is 1. Okay. So what will be the ripple here? 1 minus 1 it will be 2. Here it will be 2. And here it is also 6 and 4 will be 2.
Oh, okay, okay, sir. I got
Clear?
it, sir. Now.
Okay, okay, okay. So this, like this, you have to analyze the waveforms. Okay, this is 2 marks question. Just like one line, you can write the solution. So moving to the next question. So this is a buck converter. Okay. So but buck converter already I have derived the equation. Again I will do. So for boundary condition, how we can derive the equation? Okay, it is saying that what is the value of R in ohm? It will make the inductor current just continuous. Okay. So just continuous means it will discharge till full cycle. So let's say this is the inductor current charging and discharging. This is total time period T. From here to here, this is dt and this is 1 minus dt. So this is the just boundary condition. What will be the average value of the inductor current? This will be the midpoint. This one. This is the IL average. This is maximum. This is minimum. Get clear to all up to now? This waveforms. For boundary
Yes,
condition,
sir.
it will just touch this one. And average will be the middle of these two values. Maximum and minimum, the middle will be the average value. Okay. So we can write like this also. IL average is equal to I max plus IL mean by 2. Is it clear? This we can derive also from this waveform. This waveform is there. So from this waveform also we can derive this IL average value. How we can derive? So 1 by Ts into area. Okay. Area of this total triangle. So if you write that, we'll get this one, maximum plus minimum by 2. It clear to all? Should I derive this equation? Or all of you know this? IL average will be why it is coming at midpoint only. This midpoint only, why IL average always at midpoint. Should I derive this or I should proceed? This equation, IL average equal to IL max plus IL min by 2. IL average waveform is this blue color waveform. Okay, this is the maximum value, minimum value is 0 here. Should I proceed or I can explain this one? Can anyone reply?
Proceed, sir.
Okay, okay. Let's see. So here we can apply this in on condition. What will be the inductor voltage? It will be a source minus output. This is the VL. Okay. So LdI by dt. Okay. So this slope we can apply here. So what is this is delta IL. So we can write delta IL divided by T on. This should be equal to Vs minus V naught by L. V naught is dVs. So we can write Vs into 1 minus T divided by L. Further we can write as delta IL is equal to D into 1 minus D Vs divided by LF. This derivation is clear to all? I think already repeated many times. So what will be the boundary condition? IL average should be equal to delta IL by 2. IL average delta IL by 2. So we can write as I naught average equal to delta IL by 2. D into 1 minus D Vs divided by 2LF. D into 1 minus D Vs divided by 2LF. This we can write as V naught by R to D into 1 minus D Vs divided by 2LF, and V naught will be dVs by R to D into 1 minus D Vs by 2LF. So dVs will be cancelled. What will be the value of R? R will be equal to 2LF divided by 1 minus D.
1 minus D.
So this will be the final value. Okay.
2500 ohms, sir.
How much? 2500. 2500. So see, I will tell you one point here. So where people are doing mistake. So see, for buck converter only, this formula is there. IL average equal to I naught average. This is for buck converter only. For remaining converter, two converters, IL average is equal to I naught average divided by 1 minus D. So while deriving these conditions, in buck converter, we are directly putting I naught average. Okay. For other two converter, you have to put this value. Here only we are doing mistakes in exam. So this you have to be careful. If it will be buck boost and boost, then you have to do this one. With respect to inductor current, always we are telling either it is a discontinuous or continuous. Okay. Is it clear? So 2500 ohm is the correct answer. Everyone got this answer? Is it clear?
Sir.
Sir, clear, sir.
Okay. So this is the next question. Okay. So something here also I have changed, I think. Switching frequency 1 kilohertz. This is taking 4 kilowatt power, this load. So we have to calculate what will be the RMS value of the switch. This is the switch. So how we can calculate? First we should know the ripple. Okay. See, if it will be ripple free, what will be the switch current? When this switch will be on, this will conduct like this, and switch will be off, this will conduct like this. So if it will be a constant current, then it will be a pulse like this. Okay. It will be a pulse like this. If ripple will be low, if ripple in the inductor will be low, so we can say that the source current only, let's say this is source current, let's say 10 ampere of source current is there, and inductor current ripple is very minimum. In question it is saying. So what we can do, we can directly, this is let's say 0. Some duty ratio value will be there. Let's say this is D and this is total time period. So directly we can calculate the RMS like this. But in the case if ripple will be there, so ripple will be there means source current will be like this one. It will be a triangular kind of waveform. Okay. So in that case, we have to calculate by using the short tricks, whatever I have explained in the previous classes. So I'm going to do this one question. So what will be the ripple in inductor current? Can anyone calculate? Delta IL.
Sir, under root 1 by 3 into I naught I1 square plus I2 square into I1 I2, sir.
That formula only. So first we will calculate the ripple, delta IL. So what is the delta IL? dVs by LF. What is the D value? Can anyone tell? So this is the boost converter. So VO is equal to 1 by 1 minus D Vs. Okay. 1 minus D is equal to Vs by V naught, and D will be 1 minus Vs by V naught. So what will be the duty ratio value? Anyone tell? This D value. 1 minus Vs how much? 360. It will be 0.1.
0.1.
So D will be 0.1. What will be the delta IL? Delta IL will be 0.1 into 360 divided by LF. L how much? 10 milli into frequency 1K.
36 amps.
So it will be 3.6.
36 amps.
See 0.1 is here, na? Below it will be 10. 10 milli into 1K, it will be 10.
3.6, sir.
So see 3.6 half, how much it will be? 1.8.
Sir, 1 milli, sir. 1 milli. Okay.
And this is
Okay.
10 milli, this one.
Okay.
So, what will be the this inductor current? Can anyone tell? Average value of current through this one. First, I naught we will calculate. So, I naught will be 4 kilowatt load is there. So, I naught will be 10 ampere.
10 amps.
And what will be the source here? Average current 10 divided by 1 minus D. IS. Is it clear? 10 divided by 1 minus D. So, 10 by 0.
11.11 amps. 11.11 amps.
So, it will be 11.11 amps. It will be the, okay. So, now we can draw the waveform. Okay. What is the delta IL by 2? 1.8. So, we can draw like this one. This average is 11.11. See the average 11.11. Some minimum value will be there and some maximum value will be there. So what is delta IL by 2? Delta IL by 2 is equal to 1.8. So because delta IL is 3.6. So delta IL by 2 will be 1.8. So how much this value will be? Anyone tell? Maximum and minimum value. Here we have to add, and here to here we have to subtract delta IL by 2. And here to here we have to add delta IL by 2. Can anyone add and tell what will be the value? Second. So 11 and 1, 12, 12.9 or something, 12.9. This will be 12.9. And this will be how much? 1 second. 11 point.
9.31, sir.
And this one 9.31. Okay, 9.31. And duty is how much? Already we have calculated 0.1. This is 0.1. So how we can calculate? RMS will be 1 U into D. U will be 1 by 3 into 9.31 square plus 12.9 square plus 9.31 into 12.9 into 0.1. This will be the RMS current of the switch. It clear to all? Can anyone calculate the final value? So see this, if ripple is negligible, na, then no need to go by this way. You can see if ripple will be less, first we can check the ripple. So directly we can, if up to 2 digit or 3 digit decimal asking in the gate, no? So then we can go by this one. Okay, then it will give exact value. Otherwise directly we can assume this as if ripple will be less. So 11.11 into under root D directly we can do. Okay, that in that case we can assume this as a straight line.
3.51, sir. Answer 3.51.
3.51 or 52.
5 sir. 3.526.
Okay. So see here also I have taken the ripple less only. Let's say in question if ripple is like let's say 10, the data is like that if ripple is 10 ampere, delta IL is 10 ampere. then that value will affect this more. If ripple is less, this will not affect this value, RMS value. But if data will be set like that, if ripple will be 10 ampere, so delta IL by 2 will be 5. In that case, this ripple will affect this RMS more. Is it clear? And this duty also will affect. Duty will be more, then also this value will be more. So up to now, this type of data they have not given, but maybe in future they can give.